Alright guys, let's take a look at adding and subtracting some fractions. Should be a review of some sort, but let's walk through a few examples and make sure we are comfortable and ready to go. So let's just run right into it. Let me just start with a basic, just like a visual, and just see what you guys think. If you saw something like 1/2 plus 1/2, right? And let's just say we had no idea, we're just seeing this for the first time. Someone might come in here and say, well, I think that is, what do we got? Add the top and add the bottom, right? They might say, all right, I think it's 2/4. Okay, simply adding across the top, adding across the bottom. Okay, what if someone else comes in and says, I'm not sure, but I think I remember something about, keeping the denominator the same. So would it be 2/2? Would that be right? Which one is it? So how do we do this? So if we just think visually for a minute here, 1/2 plus another 1/2, right? So if we think about 1/2 would look like that. Here's another 1/2. Does that seem like it would equal, let's check the 2/4 option. Okay, 2/4 as a visual, 1, 2, would look like that, right? And 2/4 we should be familiar with. 2/4 is the same as 1/2. It can be reduced down to 1/2, right? By dividing the top and bottom by 2 each. So does the 2/4 seem to make sense, right? Should you be able to take 1/2 plus another 1/2 and have it equal 1/2? Does that seem right? Visually, if you take that green section plus that green section and add them together, is it still going to just equal half? No, right? Clearly not. So the trick on these is that when you do add things, okay, if they have that same denominator, you just add the numerators and keep the denominator the same, okay? Because think about, I think we all know 1/2 plus 1/2 equals a full. But I just wanted to show that visually because sometimes it gets a little confusing on what do we do with the numerators and denominators. Especially, we're going to do one in a minute here. When they are different, we have to do a little bit of work. Okay, so let's get into a few problems. For example, let's say we want to add 3/5 plus 4/6. Okay, and I'm going to do it wrong the first way on purpose, okay? Someone might rush through and say, well, 3 plus 4 is 7, 5 plus 6 is 11, right? Okay, and that is wrong, okay? Let's do it the right way, and then we'll come back and talk about how should we know, like what seems kind of wrong about that. Okay, so let's do it the right way. First, the right way is we need to get a common denominator. Okay, we need to have the same size pieces. So what you need to look at is you need to think about when you have these denominators of 5 and 6, what is their least common multiple? Okay, what do they both go into? And it's going to be best to use the smallest so that you don't have to reduce later. But really any number that they both go into would at least get this step going. So if I'm thinking multiples of 5, right? 5, 10, 15, 20, 25, 30. Well, 30 is a good one because 6 goes into 30 as well. So sometimes you just need to multiply the two numbers, right? 5 times 6, that will give you a common multiple. It may not be the least, but it will at least get us rolling. And in this case, it is the least common multiple. And all I'm going to do is rewrite this problem so that both are fractions out of 30 instead of out of 5 and 6 like they were originally. So you need to ask yourself, to get from 3/5, right, to get to the way it was written here, the denominator went from 5 to becoming 30. I had to multiply by 6. So to keep this fraction equal, I need to do the same thing to the numerator. So 6 times 3 is going to be 18. Okay, so 18 over 30 is just another way of writing 3/5. And now on the term on the right, it was 4/6. If I need that 6 to become a 30, it was multiplied by 5. So that's what I must do to the numerator to make it equivalent. Okay, so now we have the same size pieces, right? We have 18 over 30 plus 20 over 30. Now we just showed before, when you're adding or subtracting, you keep the denominator the same, and you just add the numerator. So 18 plus 20 is going to be 38. Okay, now if we want to simplify this, right, because this is actually an improper fraction, okay, and it's reducible as well. So there's a couple ways we could do this. Why don't we do it as a improper fraction, or as a mixed number, I should say. So we say, all right, 38 out of 30, right? How many times does 30 go into 38? It goes in one time, so one full time, and then there would be 8 left over. Okay, so it would be one full and then 8/30ths left. And now we can still reduce that because 8 over 30, I know they're both even numbers. I could divide them both by 2. So the 8 over 30 could be divided by 2 to become 4/15. So 1 4/15 would be a nice reduced simplified answer. Okay, let's go back to our original answer real quick and just see how did I know, or how should I have known that that was wrong. We got an answer of 7/11 originally, right? And if you think about it, we started out with 3/5 plus 4/6. Okay, 3/5 is bigger than half, and 4/6 is bigger than half. Okay, so if we add two things together and each one of them is bigger than a half, does it seem reasonable to get an answer here that's less than 1? Okay, no, it shouldn't seem reasonable. So sometimes you can kind of just remind yourself that way, and just kind of, ask yourself, does it seem reasonable? Does it seem appropriate? So in this case, definitely not. Okay, we cannot just add the top and add the bottom. That's how multiplication and division will work, though. Okay, but addition and subtraction is a little trickier. Okay, let's set up another one. Let's say we want to do 5/8 minus 1/3. Okay, so again, they're not the same denominator. Okay, what's a number that they both go into? So multiples of 8. 8, 16, 24. Okay, we're just going to have to use 24 because 24 is the smallest number to 8. Remember, I'm just looking here and here. They both can go into 24, so that means I can multiply them by something to make them 24. And we're just going to do the same thing. Okay, I multiplied the bottom by 3, so I'm going to do the same thing to the numerator. Multiply it by 3. Okay, the term on the right, to change its denominator from 3 to 24, I had to multiply by 8. Okay, so we have rewritten our problem. It's 15/24 minus 8/24. It's the exact same problem, it's just not reduced. And we don't want it reduced because I needed the denominators equal so that I could subtract and get a final answer of, subtract up top. Remember, leave that denominator on the bottom alone, 7/24. Okay, what if we start doing some mixed numbers? 2 3/4 plus 7 3/5. Okay, there's a few ways to do these. One kind of straightforward way, I think, is to change them both to improper fractions. Okay, and then we can reduce later. Now, it might not always be the fastest way, but it's kind of a safe way, and that's just the way I might suggest to do these. But you could add the 2 and the 7, and then add the fractions together and try and, simplify it back down and whatnot. I'm going to go improper fraction, and if you remember the steps on that, so to change 2 3/4 into an improper fraction, it's going to be something over 4, right? Because that's the fractional part. Now the trick is take the whole number 2 and times it by the 4 there to get 8, okay? Because 2, if you think about it, the whole number 2 is really 8/4. Okay, so we're doing 2 times 4 to get 8, but then we have to add these 3, so we actually have 11/4. Okay, 2 3/4 is the same as 11/4. All right, and then we just need to do the same process with the 7 3/5. So again, the trick is take the whole number 7 times the denominator. Okay, I'm trying to figure out the numerator here. So 7 times 5 is 35, and then we have 3 more right there. So 35 plus 3 is 38. Okay, so now we have 2 fractions that we need to add. Now it's just like the problems we did before. I need to get the least common multiple of 4 and 5, right? I'm looking at these new denominators now, so that I can get these fractions to be the same size denominator. So 4 and 5, the least common multiple, the lowest number they both go into is 20. Okay, and remember, you can always do 4 times 5 to get that. But sometimes there might be a smaller multiple than those, but it'll always at least get you going. Okay, then all we got to do, we just need to multiply the the left fraction, top and bottom by 5, right? Because the denominator needed to become 20. And the term on the right, its denominator was 5. It needs to become 20, so times 4 times 4. Uh-oh, give me a big number here. 38 times 4. 8 times 4 is 32. So 12, 13, 14, 15. Wow, big number here. I did not expect that. All right, so 152. Okay, now we are able to add these together. Okay, and we're going to keep the denominator the same. Adding the 55 plus 152 should get us 207. And now if we wanted to reduce that back down or make it into a mixed number, we could do that if we wanted to. It's all going to just depend on what the directions say. So to check that out, 20 goes into 207. I know it goes 10 times, right? Because 10 times 20 is 200. So it would go in 10 full times with 7 left over. Oops, that should have been a 20 in the bottom. Thinking ahead. Let me clean that up a little bit for you guys. Okay, so 10 full times with 7 left over, and the denominator remains 20. Okay, why don't we do one last one? Let's do a subtraction problem like that with mixed numbers. So let's say we want to do something like 8 and 9/10 minus 3 and 1/4. Okay, so I'm gonna again change these to improper fractions. Okay, just like before. I'm gonna take the 8 times 10 to get 80, and then add the 9 up top. So 89/10 is our first term. Okay, and then for the 3 and 1/4, 3 times 4 is 12, plus the 1 more is 13. Okay, so we have 89/10 minus 13/4. Okay, let's go ahead and get them with the common denominator. Here's the case, I don't have to use 10 times 4. Okay, if we just start thinking about multiples of 10, okay, 10, then 20, okay, 4 goes into 20 as well, right? So it's going to save us time to use 20 instead of using 40, because we won't have to reduce as much later. Okay, but you could get the right answer using 40. You just have to reduce it later. So we're going to multiply this left term, top and bottom, by 2, right? Because the denominator needs to go from 10 to a 20 now. So 89 times 2 should be, what, 188? Sorry, brain malfunction, 178 there. All right, and then to get from the term on the right, denominator was 4, it needs to become 20, so times by 5. Okay, 13 times 5, 15, carry the 1, 65. Okay, now we are able to just go ahead and do the subtraction. We're going to keep 20 on the bottom, and we will be left with 113 up top. Okay, in this case, again, depending on the directions, if they want you to really simplify all the way or not leave an improper fraction, we would say 20 goes in there. I know 20 times 5 is 100, so I'd go in 5 full times, and then I'd have 13 20ths remaining. Okay, so hopefully that helps. Next time we'll get into multiplying and dividing, which is actually a little simpler. All right.